Hello everyone and welcome to the first PSS lecture. In the PSS series, our focus will be on matters that relate to the art of problem solving. And to begin, I would like to discuss the concept of quantity because quantities appear in pretty much all word problems. Anytime the problem asks you to find the value of a certain property, that property is a quantity. As an example, a word problem may ask you to find the value of the mass of a car, and in this case the quantity is mass. Now let me start by giving you an overview, sort of like a roadmap of what it is that we will be talking about. We will be talking about quantities, and in particular quantity name, quantity symbol, and the value of a quantity. We talk about entities, units, which are used to measure the values of quantities, and we will be talking about unit names and unit symbols. And we'll end the discussion with a formal reading of mathematical equations and expressions. Alright, so I guess we'll start by defining the concept of quantity. And a quantity is a property of an entity that you can measure in an objective manner. Now, it's important to pay attention to everything that this sentence says. First of all, a quantity is a property, but not any property. It has to be a kind of property that we can measure in an objective manner. Let me give you an example of a few quantities. Length, area, time, mass, temperature, and there is a lot more. There is force, volume, energy, and all of these are properties that we can measure in an objective manner. We can measure length, for example, using the meter as the unit. We can measure area and come up with a numerical value, and then given a unit, we can come up with a numerical value for area. Time can be measured using, let's say, the second or the hour as the unit. Mass, we can use the kilogram to measure it with. Temperature, we can measure temperature using degrees Celsius or kelvins. And what's important about all of these properties, what's common to them, is that they can all be measured. And not just measured, but measured in an objective manner. So by that we mean that there is a process in place as to how you go about making a measurement. Now, examples of properties that are not quantities. Some examples are beauty, serenity, cruelty, kindness. All of these are properties that are not quantities because they cannot be measured in an objective manner. So you could, as an example, say, on a scale of 0 to 10, how do you rate this piece of music? But it will be a subjective kind of scale. Now, one reason it's important to know about quantities is that they are the kinds of things that we deal with in the sciences. In fact, I would say that one way to define science is that it only deals with quantities and relationships between quantities. So, for example, it deals with such concepts as temperature, pressure, and relationships between them. So if I increase the temperature, what happens to the pressure? How does that affect pressure? How does it change the pressure? And of course, sciences go about justifying any kinds of relationships that they claim that is true by testing those claims, of course. But in the end, it's about quantities and relationships between quantities. In fact, that's one reason certain disciplines, like for example, religion, does not qualify as science. Because not always do they deal with quantities. Now, at some point, of course, we might manage to measure, I guess, beauty or kindness. But until then, we don't have it right now. So until then, we'll have to. Science will not deal with these kinds of quantities. Maybe once we can measure, maybe someday we will come up with an equation for love, I guess. But we don't have it yet. And you know what? I guess I would like to be the first person actually to say this, that if we manage to measure love someday, I propose maybe the use of the heart symbol as its unit symbol. So we could actually I know what the code is for the heart. So we can write down, let's say, love is equal to 50, and and 50, and then we have the heart symbol, which is there you go. So we have love is equal to 50 hearts. That's a lot of love. Okay, let's get back to the lecture now. Let me get rid of this. All right. Okay, so these are properties. Now we would like to talk about some concepts that go with quantity. In particular, we would like to talk about what a quantity name is, what a quantity symbol is, and then later on what the value of a quantity is. All right. So the next topic, entity, by the way, is also very important. An entity. There is always an entity. A quantity always belongs to an entity, or maybe sometimes certain quantities belong to a group of entities. But in any case, there is at least one entity that's always involved. And the entity may be explicitly named or it may be implied. As an example of an entity that's named, we have the sentence that says the car has a mass of 980 kilograms. And in this sentence, mass is the quantity name and car is the entity to which that quantity belongs. It is possible, of course, in some cases for us to imply what the quantity is, what the entity is that we are talking about. So as an example of that, if I say the temperature is 20 degrees Celsius, then if the context of discussion is the weather, then obviously I'm talking about the temperature of the air being 20 degrees Celsius at that location. So the entity becomes the air at the location where the temperature was measured. All right, so quantities have names, and names are used to refer to the quantities themselves. We write them in full. As an example, length, time, mass, temperature, amount. Amount, by the way, is a kind of quantity that results when you count. We have energy, pressure, and so on. As I said, these quantity names are written in full. They are used in English sentences and phrases, and they are linguistic entities and are therefore subject to the rules of English grammar. So, for example, if a quantity name appears at the beginning of a sentence, the first letter is capitalized. An example of use of a quantity name is the table has a length of 1.2 meters. And in this case, length is the quantity name. Table would be the entity. All right, quantity symbols are a bit different. Quantity symbols are used to refer not to the quantities themselves, but the values of those quantities. Now, this distinction between the quantity itself and its value is pretty important. Let me give you first an example of a few quantity symbols. So we have L for length, T for time, M for mass, T for temperature, N for amount, E for energy, P for pressure. Now let me be formal. L is the value of length, not length, but the value of length. Now in everyday life, we do shorten this phrase and we just say L is length. But it's important to understand that L is in fact the value of length. This is why L can appear in an equation. T, lowercase t, is often used to refer to the value of time. Sometimes we use it to refer to the value of temperature in degrees Celsius. But even whatever the case, T represents the value of time or the value of temperature in degrees Celsius. Lowercase m represents the value of mass. Capital T in the sciences is often used to refer to the value of temperature in kelvins. N is the value of amount. It stands for number of. So you can call this quantity amount or number of. In the sciences, we often use N, as you might have seen in formulas like PV equals nRT. You see in this formula, N represents the value of the quantity amount. All right, so these are quantity symbols, and because these quantity symbols again represent the values of quantities, we can use them in equations. So we can write something like the value of mass is equal to 20 kilograms. Right, so again, I can use this symbol lowercase m in an equation because it represents a value and therefore it's a mathematical entity. All right, so as far as quantity symbols go, casing matters. So for example, lowercase p is often used to refer to the value of pressure, whereas capital P is used to refer to the value of power. Power is about how much energy you use in a unit time. So casing is important. And these quantity symbols are typed using the italics font style, which means that they are somewhat tilted, and it doesn't matter what the font of the surrounding text is. So in an English sentence, you can, which may be written using upright font, in case a quantity symbol appears, it has to be typed using the italics font style. So in this sense, the needs of math override the needs of English grammar. Now, something that may be a bit confusing is that quantity symbols are not really abbreviations for quantity names. So lowercase m is not an abbreviation. We do not see it that way. It's not an abbreviation for mass, for the word mass. In fact, I could choose to use a different kind of a symbol, not lowercase m, but a different kind of a symbol to refer to the value of mass. Suppose that we had agreed to refer to the value of mass using this particular kind of letter called psi, and it's a Greek letter psi. And if we had done so, then we could say that psi is equal to, let's say, 20 kilograms. And in that case, if we had agreed to use this symbol as the value of mass, no one would say that this is an abbreviation for the word mass. It's just a symbol that represents the value of mass. But you have to admit that using random symbols to represent the values of quantities would become something of a hindrance. It would be difficult for me to remember that psi means the value of mass and phi means the value of time and stuff like that. So we were smart about it, and instead of picking symbols that have nothing to do with particular quantities that we deal with, instead of that, we have picked symbols that remind us of the letter, that in turn remind us of the name of the quantity. So symbol m, which represents the value of mass, reminds me of the letter m, which then reminds me of the word mass. Alright, so they're not really abbreviations and they shouldn't be seen in that way. Now, one reason why this is important to know is that when you use m, let's say, you never put a dot after that, because again, it's not an abbreviation. Now, these are used in mathematical equations and expressions, and I gave you reasons for why we can do so, because they represent values. They are seen as mathematical entities, and they are subject to the rules of algebraic grammar. One example of use is here. The value of mass is 14.8 kilograms. Now, we normally say mass is 14.8 kilograms, and that's fine. I do that all the time myself, and I recommend that you continue to do so. But you should know in the back of your head, in the back of your mind, that this is not really mass equals 14.8 kilograms, but the value of mass that's equal to 14.8 kilograms. Okay, those are quantity symbols. Now, let me put the image back up. There we go. Okay, so we've talked about quantity names and quantity symbols. We have talked about entities. Now, before we get to talk about the value of a quantity, I would like to talk about units a bit. So the next topic is on units. Now, a unit is used to measure the value of a quantity. Examples of units are the meter, which is 1 unit we can use to measure the value of length. There are others, of course. And there is a square meter, which is a unit that can be used to measure the value of the quantity area. Second can be used to measure the value of the quantity time. Kilogram is used to measure the value of the quantity mass, and Kelvin is one unit we can use to measure the value of the quantity time. Now, for every quantity, there are multiple units that usually there are multiple units that can be used to measure their values. So for time, I can use the second, I can use minutes, I can use hours, I can use decades, centuries, and so on. For mass, I can use the kilogram, I can use gram, I can use pounds, and so on. Units have names, and also the rules that go with unit names are very similar to the rules that go with quantity names. Unit names are used to refer to the units themselves. Examples of unit names again is the meter, second, kilogram, Kelvin, mole, joule, Pascal, and so on. These ones are written in full. They are used in English sentences and phrases. As quantity symbols, these are linguistic entities and are therefore subject to the rules of English grammar. Now, in SI, which is the International System of Units, this is the default measurement system in the sciences. By agreement, unit names begin with lowercase letters, unless, of course, the rules of English grammar dictate otherwise. Because these are names, they're not mathematical entities, and so any rules or any conventions that we have, we don't really care about them that much. So if the rules of English grammar require that we should change our conventions on quantity names and unit names, then we allow that. So for example, in SI, as I just mentioned, unit names begin with lowercase letters. We write Pascal with a lowercase p, Kelvin, lowercase k, Newton is another one. These unit names come from last names of individuals, and so by the convention is that if or the reason that we have this convention is that if we write Kelvin, let's say, with a lowercase k, then we know we're talking about the unit. Whereas if we use capital K, then we are talking about the individual. Now, if Kelvin appears at the beginning of a sentence, though, then the rules of English grammar do apply. So K should be capitalized in that case. All right. Okay, one example of use is the table has a length of 1.2 meters, and you can see the use of a unit name in this sentence, the meter. Okay, next topic is unit symbols, and very similar to quantity symbols. These are used to refer not to the units themselves, but the sizes of units. Note that we talk about the value of a quantity and the size of a unit. Examples of unit symbols are lowercase m, which represents the size of the unit meter. Lowercase s is used to refer to the value or the size of the unit second. kg, both lowercase, no spacing in between, refers to the size of the unit kilogram. Capital K refers to the size of the unit Kelvin. MOL, all lowercase, this refers to the size of the unit mole, which is a unit of counting, and I will talk about the unit and what it is in detail later on. Capital J for joule, this represents the size of the unit joule, and capital P followed by lowercase a. This represents the size of the unit Pascal. Casing matters. Lowercase s is often used, not often, it is used to represent the value of the unit, or my apologies, the size of the unit second. Capital S is used to refer to the size of the unit Siemens, which is a unit that's used in measuring the value of electrical conductance. These symbols, unit symbols, are typed using the upright font style. And again, it doesn't matter what the font of the surrounding text is. They should always be written using upright font. This allows me to differentiate between mass, the value of mass, and the size of the meter. So as an example of this, if I write down, let's say, lowercase m, and it's in italics, then I know that I'm talking about the value of mass. But if I write m using upright font like this, then I know that I'm talking about the size of the unit meter. So you see the value of mass, the size of the meter. All right, what's next? We've got, as quantity symbols, these are unit symbols are not abbreviations of unit names. But again, we've been smart about it, and instead of just picking some arbitrary symbol, we pick a symbol that reminds us of the first letter of the name of the unit. So lowercase m, which is a symbol representing the size of the unit meter, reminds me of the letter m, which in turn reminds me of the size of the word meter. Because they represent sizes, unit symbols can be used in mathematical equations and expressions. And again, these are mathematical entities and are therefore subject to the rules of algebraic grammar. Examples of use: the value of mass is 14.8 kilograms. So this would be read formally as the value of mass is 14.8 times, that's the spacing in between, times the size of a kilogram. Now the value of a quantity is the next thing we want to talk about, and that's this topic. One example of a value of a quantity is 452 kilometers. And in 452 kilometers, the 452 is called the numerical value of the quantity, and it only refers to the number part. So in this problem, my apologies, this should have been 452. Let me actually change that so there is no confusion here. Okay, so so we have 452 in this example, and that would be the numerical value of the quantity. Now, an empty space is always placed after the numerical value. This empty space implies that we are multiplying. It implies multiplication. And following that, we put down the unit symbol, which sets the size of the unit. So officially, such an expression is read as 452 times the size of a kilometer. Although again, informally, we always say 452 kilometers, and you should continue to do that. But again, it's important to know that what you're really saying is 452 times the size of a kilometer. All right, so the last topic for today, for this video, is the formal reading of mathematical equations and expressions. And we have already covered the topic, but just as a reminder, the formal reading of m equals 14.8 kg is the value of mass is 14.8 times the size of a kilogram. So the value of mass is 14.8 times the size of a kilogram. Once again, informally, we would just say mass is 14.8 kilograms, and that's fine, so long as we do understand that what we are really saying is that the value of mass is 14.8 times the size of a kilogram. Now, you should differentiate also between expressions like this, which represents which says 4 times the value of mass, and expressions like this, which says 4 times the size of a meter. You see here, I have no spacing between 4 and m. Also, m is written or typed using the italics font. and so this is read as 4 times the value of mass. With this one, I have 4 followed by an empty space, followed by m, written using upright font. And this means that I'm talking about 4 times the size of a meter. Now, when you write by hand, you cannot be so careful in terms of whether you write the symbol in italics or upright font. It takes time. But at least the spacing can help out. So if you put a bit of space, then that means that you're talking about a measured value. You're talking about a unit. And if you don't use any spacing in between, it means that you're talking about the value of a quantity. Now, please stay away from expressions like these two. They are pretty confusing. So for m here, I'm not quite sure whether the person meant to say 4 meters and they forgot to put a space in between 4 and m, or if they meant to say 4 times the value of mass and they forgot to write m or type m in italics font. And this one is also confusing, because on the one hand, there is spacing, which makes me expect that I'm talking about the value of the size of a unit, and that's not the case, because m is written using italics font. So such expressions are confusing, and you should stay away from them. Okay, everyone, thank you so much for watching this video. If you have any comments, please let me know. More are coming, and please stay with me. You're gonna love the series. I will be gone again in 3, 2, 1.